Question 15. A shop prints designs on t-shirts which look strikingly but not really familiar to pyramids based in Giza, because it looks like a pyramid from head down, bird's eye view. So they use this formula to work out the price for printing a design. Now the price of the t-shirt is 60 pence times the number of colors used, okay? And then plus an additional £1.25, probably for delivery or just getting the t-shirt itself. So what is the price for printing a design that has 3 colors? Well, since you've got 3 colors, it'll be, in this case, 60 pence times 3. So 3 lots of 60 is 180, so it'll be £1.80 plus £1.25. And that gives us a grand total of about £3 and 5 pence. Okay, easy stuff. So just add them. If you're not sure how to add decimals, just line them up like 180 plus 125 as if they were hundreds. Okay, so now Amina has only £5 to spend in printing a design. Okay, so remember, this was the number of colors times 60 plus 125 would be the price of it. So since it's £5, this means you're going to get a fixed number of colors. Okay, so what is the greatest number of colors she can have in the design? So let's kind of think of it as an equation, yeah? Let's work in pennies because there's a lot of decimals involved. So instead of £5, we're going to say that she can spend so far 60p times number of colors. So let's say 60p times the number of colors plus £1.25 or 125p has to be equal to 500 pence. So this is the equation. To make your life easy, because we're always going to pay £1.25 in the end, let's just ignore the 125, make it 125p less. So this means instead of £5, it'll go down to 375p. Now the question is, how many 60s will fit into 375p? Well, you can see that if we just go and count in our 60 times table, or better yet, 6s, will be 6, 12, 18. So just add zeros, by the way, to make it 60s. 24, 30, 36, and so on. You'll notice that actually, after this number, you get 420. This is when the limit occurs. So basically, you can say that you can say that 60 goes into 375 exactly 1, 2, 3, 4, 5, 6 times with some remainder. And that's it. That's literally the greatest number of colors she could have in a design. Okay, number 16 now. So a book has 276 pages. Amina has read 1/3 of the book. How many pages are left for Amina to read? So if she's read 1/3, that means there are now 2/3 left of the book. And we know the book has 276 pages. So that's the question we need to solve, is this. Now the quick way to find fractions is to always find 1/3 and then times it by how many thirds you need. So to find 1/3 of 276, just divide that by 3. And this is just easy. So let's have a look. How many 3's go into 2? Well, it can't. How many 3's go into 27 then? Well, we know it goes 9 times with no remainder. And how many 3's go into fit into 6? Well, twice. And because we want 2/3, let's double it. So double 92, well, double 90 is 180, and double 2 is 4, so it's 184. Easy. Okay, question 7 now. On a dice, the sum of the dots on opposite faces is always 7. Okay, so this means if it's 4 on the top, then when it's on the ground, facing the bottom, facing the ground is 3. Okay, so draw dots on the 3 empty faces of the net. So the net is literally the face if you open it up, and it would look like this. So we just have to pretty much fill out the 3 blanks with the right dots. So think of it this way. Let's consider making this one the ground, yeah? So this is now facing the ground. So this is facing the floor. This means if you lift this part up, this number 4 will lift up. So this would be a 4 here. So if you lift this one up, it must be a 3. We can immediately do 3 across here. So this is the wings of the ground. So we're at the moment we're here. So here's the base, yeah? Now if we lift this part up, this is going to correspond, so this is going to be another wing, but this time the front wing. We need a back wing, and the only way to get back is to shift this one to across the 6, so the 6 will be here. So this means if this is 6, then this must be a 1. So now you could just realize what the final one is. We've got 1 here, we've got a 2, we've got a 3, we've got a 4. So anything remaining is a 5. So we can do 1, 2, 3, 4, 5. And that's it. Guys, yeah? So 18. Now this is a diagram of a vegetable garden. Okay, it shows the fractions of the garden planted with potatoes and cabbages. Oof. love vegetable gardens. So apparently in this garden, we can see that 2/3 are potatoes, a quarter is cabbages, and the rest are carrots. Now, what fraction of the garden is carrots? This is actually quite easy. In general, when it comes to fractions, we need to realize that when you add up all fractions, it must add up to make a whole fraction, a whole one. So let's go ahead and add 2/3 and 1/4, yeah? So we can say that 2/3 plus 1/4, well, actually, to work this out, we need to have common denominators because you can't actually add this. So the only way you can make them the same is if you both raise them up to the same denominator. So let's have a look. If you go 3s and 4s, they both appear in the 12. So you can see that the only way to make a common denominator if they were both over 12. And to get the first fraction over 12, we need to multiply up and down by 4. So 2 times 4 is 8, because 2/3 is the same as 8/12, and vice versa. To get 4 to 12, we need to multiply this second fraction by 3. So 1/4 up and down times 3 is 3/12. And that's it. So 8/12 plus 3/12 is going to give us 11/12. So that is the value of everything but the carrots. So 11/12 make up potatoes and cabbages, then carrots must be the remainder, which is 1/12. Okay, not bad as well. So next one.